this equation behind me may look like a nightmare for IGCSE students, whereas this is just a regular Tuesday morning for A level students. If you want to be able to solve a question like this in under 60 seconds, watch this short video to the end. If you want to be able to solve complex calculus questions, you need to understand this concept down to your very bones. Hi guys, it's Farida. Welcome to my YouTube channel. Today we will be learning about the bedrock of algebraic manipulation, indices and surds. Let's get into it. Okay, so let's start with indices. There are three main rules that you need to know, but there are two secret ones that people usually trip over and examiners like to test students on. Let's start with the first rule, the multiplying rule. When two identical bases are multiplied, their powers are added together. That's it. The dividing rule. When two same bases are divided, their powers are subtracted. Next, when you have power to power, they are multiplied. Let's go to the two secret rules now. These are a bit tougher to understand. The negative rule. When you have a negative power, automatically it becomes a fraction and the number here becomes the denominator. Think of the negative sign as a ticket to the the denominator side, right? Think of it like that. Next, we have the fraction rule. When you have a base with a fraction power, basically the bottom, the denominator becomes the root and the numerator becomes the power. Think of it like this: power up, root down. So since m is up here, that means that m is the power and n is down, so n is the root. So these are the five main rules that you need to understand. Let's apply this in a question. Look at this question. 16 raised to power minus 3 over 4. So let's start with the negative sign. This would automatically become 1 over 16 raised to power 3 over 4. Right? Let's work on the fraction. So we know power up, root down. So this is the same thing as 1 over 16 cube of the fourth root. Now the fourth root of 16 is 2 and 2 cubed is 8. So automatically the answer of this is 1 over 8. And that's all for indices. Next, let's go to surds. Surds. So what happened when we have a root and it doesn't give us a nice whole number? Instead, it gives us an irrational root like root 2 or root 3. In this case, this is where surds comes in. Basically, we have to simplify these, and there are two rules for this simplification. The first rule is root a times root b is the same thing as root ab, right? And then we have root a over root b is the same thing as root a over b. These are the two rules that are going to be needing a simplification. For example, if you have root 50, right? In this case, you need to think of the largest root number, the largest square number in 50, and that's going to be 25. So root 50 is the same thing as square root of 25 times 2, which is root 25 times root 2. So this is the same thing as 5 root 2. That's how you simplify surds, roots like that. Okay, then let's go to the simplification of fractional surds. So what if you have something like this? 4 all over, no. So what if you have something like this? 1 over root 2. In this case, all you need to do to rationalize the denominator is multiply the numerator by root 2 and the denominator by root 2. In this case, we get root 2 over 2. Because when two square numbers of that two same square numbers are multiplied, they become a whole number. So root 2 times root 2 becomes 2. So this is root 2 over 2. So these are simple surds. Now let's go to more complicated ones. What if we have something like this? 4 all over 3 minus root 5. Now, in this case, we won't be multiplying the numerator and the denominator by this. Instead, we'll be switching the sign in the denominator and multiplying both numerator and denominator by that. Now, let's see how this works. So, the numerator will be times 3 plus root 5. The denominator will be times 3 plus root 5. So let's work this out now. So this 4 will be multiplying this whole 3 plus root 5. So 4 times 3 is 12 plus 4 root 5 all over this times this. Basically, everything is going to be multiplying each other. So let's go with this first. This 3 multiplying this 3 is 9. This 3 multiplying this root 5 is 3 root 5. This minus root 5 multiplying 3 is minus 3 root 5. And this minus root 5 multiplying plus root 5 will give you minus 5. Right? So basically, like this, you have rationalized. Now, what's left is simplification. So this is 12 plus 4 root 5 all over. These cancel out. 9 minus 5 is 4. We can cancel 4. So this is 4. 4 in 12 is 3. And 4 in 4 is 4. So this is 3 plus root 5 all over 1. So this is 3 plus root 5. That's how you must rationalize the denominator. And that is going to be all for this video. Thank you for watching to the end. And in the next video, we'll be learning everything to know about quadratics. I am pretty sure that question I showed at the beginning of the video, you can solve it very easily now. You can go back to the beginning and try solving it. I trust you'll be able to. In the description, I'll leave a PDF note of some free questions that I can use to practice these concepts that you've just learned. Thank you so much, and please like and subscribe. Bye.